Welcome to clickmyproject.com. Our product title is a novel zero current transition PWM DC to DC converter with coupled inductor. Next we see about abstract of our product. In this proposed implementation, we design a zero current transition in discontinuous conduction mode converters. Just compared to hard switching converters in discontinuous conduction mode, the ZCT discontinuous conduction mode conductors have similar current stresses and conduction losses and much reduced turn-off switching losses. At the expense of increased voltage stresses, zero current, zero voltage switching is maintained for a wide range of loads and voltage conversion ratios without the need for auxiliary active devices. In AC to DC applications, high power factor is obtained automatically without the need for active control over the input current. In order to realize zero current transition condition, the auxiliary circuit consists of a coupled inductor, a capacitor and an auxiliary switch, which also operates with a zero current transition condition. Moreover, the coupled inductor plays an effective role in achieving soft switching conditions. This approach includes two categories of controlling, such as open and closed loop control. This overall simulation is implemented in the MATLAB Simulink environment. Next we see about flow diagram of our product. This is our flow diagram. In this flow diagram consists various modules, that is input DC source and ZCT technique and coupled inductor, PWM generator, DC to DC converter and load. Generally the DC to DC converter using of MOSFET switches and active elements of coupling inductor and capacitors. And first we see about the input DC source. A power supply is an electronic device that supplies the electric energy to an electrical load. The primary function of a power supply is to convert one form of electric energy to another form of electrical energy. As a result, a power supplies are sometimes referred to as electric power conversion. Some power supplies are discrete standalone devices, whereas rather than built into larger devices along with their loads. Next, the input DC supply is given into the DC to DC converter. The DC to DC converter consists various elements such as MOSFET switches, inductor, capacitors and diodes. The MOSFET switches is switching pulses is getting from the PWM generator. The PWM generator is connected with the ZCT technique. That means the pulses is generated in terms of zero current transition technique. Zero current transition technique is nothing but it is a soft switching technique. Expect that the capacitor C and the inductor L form a multi-resonant tank. With the help of these elements, the technique is used to conduct the current in zero transition. So the overall advantages of this technique is reduce the switching losses, voltage stresses and also increases the efficiency. And next one, PWM generator. PWM generator is nothing but is a method of controlling the amount of power to a load without having to dissipate any power in the load driver. Okay, then after that the pulses is fed into the MOSFET switches. The MOSFET switches is coupled with that inductor. Due to the inductor value, the output voltage will be buck. Here we using the ZCT technique in the buck DC to DC converter. Buck DC to DC converter is nothing but the output voltage is lower than the input voltage due to the connecting of the acting elements. Next we see about running process of our product. In this proposed design is done in MATLAB simulating environment. The version is MATLAB 2013A. First we open the MATLAB window and create a MATLAB model file. After creating the model file, we create a name for that MATLAB model file. After that, we click the simulating library browser. In the simulating library browser, various elements are in there. For our circuit, whatever we record, that elements is tracking from the library browser to corresponding model file. After tracking that elements, we arrange the elements as per the circuit in this paper. After connecting the circuit, we click the run icon. After clicking that run icon, the output will be displayed in the corresponding scope in the MATLAB designed circuit. First one we see about the input voltage. The input voltage is 120 volt. The input source is DC, so the voltage will be constant. And next one, the input current. Due to the series resistance, the input current like this. And next one, the VDS and IDS waveform. Due to the zero current transition, the voltage will be maximum, then the current is zero. After the voltage will becomes to zero, the current rising like this. And next one, the output voltage. The output voltage is 90 volt. The buck converter, the output is voltage is lower than the input voltage. That means the output voltage is reduced from the input voltage. 120 voltage is reduced to 90 volt. And next one, the output current. The output current is 9 amps. In the circuit, the load resistance value is 10 ohms. So the value of output current is 9 amps. Next one, the output power. The output power is a product of output voltage and output current. So the output power is like this. So using of ZCT condition, the overall efficiency will be increased. That means the voltage stress will be reduced and the switching losses will be reduced. Thank you for watching this video.